While studying math in the primary level, you would have studied the significance of the number 0 and 1, right? And the significance of these two numbers, right? In vector theory also we have something known as zero vector and a unit vector, and we'll be talking about these two types of vectors in this particular video. Let us begin by talking about the zero vector, right? Let us say we have two vectors A and B, right? And let us say vector A is equal to vector B. When we say vector A equal to B, that means both the vectors have same magnitude and same direction, right? So if we have two vectors A and B, and if A equal to B, then what would happen if we subtract A minus B from A, right? Quite obviously, since these two vectors are equal, we would end up with something known as a zero vector, and this is how we denote it, 0, right, with an arrow above it. So this represents a zero vector. What does it mean? It means that when we have subtracted these two vectors, no more, the vector does not exist. That means this vector does not have any magnitude, nor does it have a specific direction, right? Now this may seem a bit odd that when we do not have any magnitude and we do not have any direction, how can a vector exist, right? Yes, that's true. There is no vector which exists when we subtract B from A and when A and B are equal. But still we identify this as zero vector, because if any of these values changes, right, let us say these are displacements or velocities or accelerations and or forces, and if any one of them changes, then a vector would come into existence. For the specific values, for these two values, when they're equal, we get a zero vector. But if any one of them changes, then we would have a vector which would have magnitude and direction. And hence, we have this concept of a zero vector. This particular zero vector has got a few properties, right? Properties which are very, very self-explanatory. For example, vector A plus zero vector would give us vector A. Quite obviously, we are adding a vector which does not have magnitude and direction, so that would give us the same vector. Similarly, if you multiply a number with zero vector, then you would get a zero vector, right? Thirdly, if we have 0 multiplied by a vector, right? This is 0 multiplied by vector, we'll get a zero vector, right? So these are some of the properties of the zero vector. Now, what you must be wondering now is that if this vector does not have a magnitude and direction, what is its significance? Why do we need to study this? There are situations when you're dealing with mechanics and when you're dealing with vectors, when the concept of zero vector becomes important. For example, we may have a situation wherein we may have a question like, the question could be, what is the displacement of a stationary object? Stationary body. Quite obviously, if you try to answer this question in terms of vector, we would get zero vector as the answer, right? So when the object is stationary, the displacement vector is 0, right? But the moment the object starts moving, this zero vector will cease to exist. You will have some other vector which will have magnitude and direction, right? So that is why this concept of zero vector is important, because when a body is moving, the displacement will have some value. When the body becomes stationary, when it stops moving, you'll get the displacement as zero vector, and then if it again starts moving, again you will have some vector. We may have similar situations like, what is the acceleration vector of an object moving with constant velocity? For example, what is the acceleration vector of an object moving with uniform velocity? Again, in this case also, you know the answer would be zero vector, right? Because when a body is moving with uniform velocity, there is no change in velocity, acceleration is 0. So as long as the object is moving with uniform velocity, acceleration vector is zero vector. The moment its velocity changes, right, you will have some value, you will have some vector, and a vector would come into existence. So zero vector represents or when you add or subtract two vectors, you may get zero vector at a given point in time for given specific situations like displacement for a stationary body or acceleration for uniform velocity. The moment these conditions change, a vector comes into existence. So this is why we need the concept of zero vector to represent situations like these, right? There are quite a few situations when you have, I'll end this video with one more example, right? If vector A plus B plus C plus D, for example, is a closed polygon. Find the resultant vector. So we studied earlier that when we draw vectors one after the other when we are adding them, and if we get a closed polygon, right, then the resultant is 0, and which is represented by a 0 vector. The moment this is not a closed polygon, meaning that if any one of these vector changes, you will get a vector as an answer. But if it is a closed polygon, you will get 0 vector as an answer. So this is why we have introduced the concept of 0 vector in vector theory, right? And while doing some numericals, we'll come across the application of 0 vectors, and that will help you understand the concept of 0 vector much better. Thank you.